Hi guys, so welcome to the part 2 of explanation of standard deviation with Python. We have had the first part where we talked about standard deviation and we looked at how to explain standard deviation using Python. But now I want to make a further explanation. Now to make a further explanation, I want us to see an image. So let's an image of standard deviation. How am I going to do that? So of course I checked out how to do that. So the first thing I want to do is I want to import some libraries, right? So I'm going to say from PIL import image. Yes. Then I also want to use, I'm going to import a visualization library, which is a matplotlib, and I want to use the pyplot function in it as plt. Right, now I already have an image, so I'm basically going to load the image. So I'm just going to load the image. And to do that, I'm going to write image here. And then I'm going to say, I basically have the image as std image. Yes, I have a JPEG file of it. Then I am just going to say image. And I'm going to say image dot open, and I'll open it, and inside I'm going to write image. Right, then now I'm basically going to display the image. And to do that, I'll say plt dot image show, and inside I have my image. Then I don't really want anything, the axis, so I just say axis off. Then I will plt.show. I should show this. Let me see. Does this work? Yes, it does. So look at what we have here. We have standard deviation image. I just basically went, you can see where I got it. It's not, yep. So that's what it is. So now what you see here is you see the mean, and you see standard deviation is trying to, understand how far away we have from our mean. Look at that. So this will mean one standard deviation away from the mean, and to the mean. You can see that. So standard deviations have, you can see you can have 2 standard deviations, 3 standard deviations. Now I also want to explain this in a way that it's a whole lot intuitive. So first off, I am going to create 2 lists, right? So I'll create 2 lists, and they're going to have scores inside. So I'm going to call this score underscore 1, and inside here I'm going to just have random numbers. I have 85, 90, 75, 95, 80. How many do we have? We have, yes. Then I'm going to have score underscore 2, and inside I am going to have another set of numbers, maybe 50, 32, 45, 90, 21. Now we have 2 scores here. You can see that we have 2 scores. Now I want to find out their mean, right? So to do that, okay, I'll import. Let me import a statistical package. See how Python makes it pretty easy? Statistical. Yes. Python makes learning statistics pretty easy. Now I don't have to go on to do the drudgery in doing all this. I just import a package. So I import statistics and I give it an alias. I call it st. So now what I'm just going to do here is I'm going to find the standard deviation for score 1 and score 2. So I'm just going to say score, I'm just going to say st dot standard deviation, then I put score 1 here. So you see that? And so this is the standard deviation. Then I say st dot standard deviation for score 2. Oops. Now you can see how spread out they are. Now, the reason why we don't understand a little bit of what I just did right now is that I'm going to come back here. So this is the standard deviation, STD for short. I am going to come over here and I'll show you the st dot mean of score 1. Now this is going to put this into perspective, right? So you see 85. Then I come over here and I get st dot mean for score 2. Now you see, now when you look at the mean of score 1, it's 85. And the mean of score 2, this is the mean, is 47.6 for this. Now we want to know how far away, all these other scores are from 85. And we can tell using this number. You see that? 7.9. And we want to know how far away in score 2, you see 47.6 is the mean, and the standard deviation is this. It's telling you how spread away they are. And if we come back here, you can now see that. So this is the mean, and in our case here, this is 85 for score 1, and this is the going away from the mean. So that means 75 to 85, and we have 90 to 85. So you see the way they are. So that's how standard deviation measures the dispersion of a data set relative to its mean, and is calculated as the square root of the variance. So that is what the standard deviation is, and that's what we did in here, that Python did in the background, and that was our explanation over here. For you to see this video, you have to go to the video before this, and you see it. So this is a further explanation of what standard deviation is. And just to add a little bit for good behavior, standard deviation, with standard deviation, there is a low standard deviation means that the data points are generally close to the mean. So you see, again, a low standard deviation, 85, they are close to the mean, and you can agree. Look at that, 90 is closer to the mean, 85. A larger or a high standard deviation indicates that the data points are spread out. We have 47.6 as the mean and 26.27 as the standard deviation. So they are spread out. And if you again look over here, you can tell, like if you have 47.6, see 90 is quite spread out, 21 is quite spread out, 32 is quite spread out, 50 somewhat spread out. So that is further explanation of standard deviation, and I hope you get the intuition in this, because with this you get to understand how well data is spread out, how you understand if we are going to talk about issues around finance, research, investments, you are now going to know how well this is. For instance, in finance, a high standard deviation indicates higher risk in investment. So stuff like that. So right, I hope you guys got this. Like, subscribe, share with anyone trying to understand all these basic statistical concepts.